What if the future of car manufacturing isn't more robots, but fewer of them? What if the biggest breakthrough in electric vehicles isn't batteries, software, or self-driving, but a single machine so powerful it can erase entire factories overnight? That's exactly what Tesla is preparing to do right now, deep inside Giga, Texas. Tesla is quietly setting the stage for what could be the most dramatic production shift the auto industry has ever seen. Entire lines of robotic arms, miles of conveyors, and thousands of tiny stamped components may soon disappear, replaced by one colossal machine designed to do in seconds what used to take hours. And this isn't just a bigger press. It's a manufacturing weapon that could permanently break the cost structure of building cars. At the center of this shift is something called the 50,000-ton Giga, a machine so extreme that most engineers originally thought it was impossible. To understand why this matters, you first have to clear up a common misunderstanding. The 50,000 tons doesn't refer to the weight of the machine. It refers to clamping force, the pressure used to hold a mold shut while molten aluminum is injected at insane speeds. That force is what determines how large, thick, and complex a single casting can be. Traditional car manufacturing relies on hundreds of stamped steel parts that are welded, riveted, and glued together by massive robot teams. Tesla's approach is the opposite. Instead of assembling complexity, it eliminates it entirely. This idea didn't start at 50,000 tons. Tesla first shocked the industry by using a 6,000-ton press to cast large sections of the Model Y's rear underbody as a single piece. What used to be dozens of parts became one. Fewer robots, fewer failure points, faster production. The rest of the world took notice, especially China. When Tesla pushed to 9,000 tons for the Cybertruck, Chinese automakers refused to stay behind. That's when companies like XPeng introduced 16,000-ton hypercasting machines, which are currently the largest operating die-casting systems on the planet. For a moment, it looked like China had taken the lead. But matching competitors has never been how Elon Musk plays the game. Instead of building something slightly better, Tesla jumped straight to something absurd. Reports suggest Tesla's next gigapress will deliver roughly 500,000 kilonewtons of clamping force, more than 3 times what XPeng's machine can generate. That difference changes everything. While a 16,000-ton press can cast one major chassis section per cycle, the 50,000-ton gigapress is designed to cast up to 5 complete vehicle chassis at the same time. Not sequentially, not one after another, all at once. That single capability alone is what allows Tesla to talk about production speeds, measured in seconds instead of minutes. More force doesn't just mean bigger parts. It means thicker structures, stronger load paths, and shapes that were previously impossible to manufacture in one piece. It also means far fewer welds, which are one of the most common sources of structural weakness in manufacturing defects. But this is where things get tricky. As machines scale up, precision becomes exponentially harder. Molten aluminum has to be injected fast enough to fill the mold before it cools, but not so fast that it traps air and creates internal voids. Cooling must be perfectly controlled, because uneven temperature changes can warp a casting the size of a mattress. The margin for error shrinks to almost nothing. This is why most automakers can't simply copy Tesla, even if they had the money. A machine like this demands ultra-advanced cooling channels, AI-driven quality inspection, real-time sensor feedback, and software tightly integrated with hardware. According to statements from Elon Musk, Tesla had to design entirely new internal cooling systems just to make this scale possible. Bigger casting machines don't forgive mistakes. At this level, even a microscopic flaw can scrap an entire multi-ton component. What makes this story even crazier is that the gigapress almost never existed. When Elon Musk first pitched the idea of casting massive portions of a car in a single shot, nearly every major decasting manufacturer turned him down. They said it couldn't be done, that the machines didn't exist, that the tolerances were impossible. Tesla was effectively told no over and over again. As a last attempt, Musk reached out to Giga, a company known for building large industrial presses. Giga didn't say yes, but they didn't say no either. They said maybe, that maybe changed the industry. Tesla and Giga worked together for over a year, redesigning and rethinking nearly every aspect of high-pressure die casting. Engineers were reportedly forced to revise designs constantly as Tesla pushed for more size, more speed, and more integration. It was messy, it was risky, and it worked. The original Giga press was born, and now Tesla is taking that same philosophy to an extreme most manufacturers still can't process. Then there's the cost. On paper, a 50,000-ton Giga press looks insane. Estimates suggest it could cost anywhere from $40 to over $60 million. That number alone scares off almost every legacy automaker. But that's where the misunderstanding lies. This machine doesn't replace one tool. It replaces entire factory sections. Traditionally, a vehicle underbody might consist of 70 to 100 separate stamped parts, assembled by hundreds of robots across massive floor space. A single gigapress can collapse that entire operation into one machine and a handful of support systems. Less labor, less energy, less maintenance. Over time, the machine pays for itself. It also reshapes the factory itself. With fewer robots and shorter assembly lines, Tesla can shrink factory footprints by as much as 30 to 35%. That means lower real estate costs, faster construction timelines, and easier global expansion. It's not just manufacturing efficiency, it's operational leverage. And when paired with aluminum alloys that don't require post-casting heat treatment, Tesla saves even more time and energy per vehicle. This is where legacy automakers start to struggle. Their factories are built around steel, stamping, welding, and decades-old production logic. Retrofitting them for megacasting would require shutting down operations, redesigning supply chains, retraining workers, and rewriting software systems. For many of them, the cost of change is higher than the cost of staying inefficient. Tesla doesn't have that problem. Its factories were designed for disruption from the start. The 50,000-ton Gigapress isn't just a machine, it's a signal. It tells the industry that manufacturing itself is being rewritten. Just as Ford's assembly line once transformed the world and Toyota's lean manufacturing changed efficiency standards forever, Tesla's megacasting approach is redefining how vehicles are built. This isn't about building cars faster. It's about removing everything that slows manufacturing down. And that leads to the real question. If Tesla can cast 5 vehicle bodies in a single shot, in seconds, with fewer robots, fewer parts, and lower costs, who's actually prepared to compete with that? Because this isn't a future concept anymore. It's already taking shape. And once it scales, there may be no going back. And the consequences of that scale go far beyond speed alone. When you remove hundreds of welded joints from a vehicle, you don't just simplify manufacturing, you fundamentally change how the car behaves over its entire lifespan. Fewer joints mean fewer weak points, fewer vibrations, and fewer long-term fatigue issues. It also means tighter tolerances, better crash energy distribution, and more predictable structural behavior in real-world conditions. This is why reports suggest Tesla isn't just using megacasting to save money, but to redesign vehicles around strength and simplicity rather than patchwork engineering. There's also a supply chain ripple effect that most people overlook. Traditional auto manufacturing depends on thousands of suppliers, feeding stamped parts into factories on tightly coordinated schedules. One delay can stall an entire line. By collapsing dozens of components into a single casting, Tesla quietly cuts dozens of suppliers out of the equation. Fewer trucks, fewer delays, less inventory sitting idle. In an industry where margins are razor-thin, removing even a small amount of logistical friction can translate into massive financial advantage over time. Then there's weight. While aluminum castings are large, they often end up lighter than equivalent steel assemblies once reinforcements, brackets, and overlapping materials are removed. Less weight means better efficiency, longer range, and lower battery requirements. And battery size is one of the most expensive parts of any electric vehicle. So by optimizing structure through casting, Tesla indirectly reduces battery costs without touching the battery itself. That's a second-order advantage most competitors aren't even accounting for. But pushing manufacturing this far comes with serious risks. Scaling a 50,000-ton press isn't like scaling software. If something goes wrong, the failure is immediate and expensive. A single flawed casting can represent thousands of dollars in wasted material and energy. A systematic defect could halt production entirely. That's why Tesla's approach reportedly leans heavily on real-time monitoring, AI-driven inspection, and rapid feedback loops that detect microscopic defects before they cascade into larger problems. This isn't just industrial hardware anymore. It's a cyber-physical system operating at the edge of what materials science allows. And while some critics argue that putting so much reliance on one machine creates a single point of failure, Tesla appears to be betting on redundancy through replication rather than diversification.